Okay, this particular video is over polynomial inequalities, which isn't really a section out of your book. It's already contained in part of the other ones, but we do have a separate homework on this, so I want to work some problems out of that homework section. So a polynomial inequality is basically a polynomial equation, but instead of an equal sign, it has one of the four inequality symbols: less than or equal to, greater than or equal to. We're going to take a look at this first problem here. We're going to be graphing them both in what's called interval notation and on the number line. Now, in some places, you're taught to draw it directly on the number line, but I prefer to do mine directly above the number line so that I can see exactly where they are without covering up part of the number line. So what we're going to start with is we're going to start with the equation that we're given. In this case, we're given 5x is less than 8x minus 9. I need to isolate my x variables on one side of the inequality. We have to be very careful with inequalities because although we are allowed to add or subtract any number we like without changing the inequality, we are not allowed to multiply or divide by any number unless if it's a negative, we'll have to turn the symbol around. I generally try to avoid having to use that rule by always moving the smaller x term to whichever side would cause the x term to be positive. In this case, since I have 5x on the left and 8x on the right, the 5x is smaller than the 8x, so I'm going to move the 5x to the right side by subtracting 5x. That means I will want to move the minus 9, since it doesn't have x attached, by adding 9 to both sides of the inequality. Because I'm only adding and subtracting, that rule about reversing the symbol does not come into play. This gives me 9 is less than 3x. This means now that when I divide, I will be dividing by a positive 3, not by a negative 3. So my next line would be 3x divided by 3 on the right and 9 divided by 3 on the left. Because the 3 I'm dividing by is positive on both sides, I do not have to reverse the inequality symbol. This gives me 3 is less than x. Remember that you read this symbol from the left side to the right side. When you encounter the little n first, it's less than. If you encounter the wider n first, it's greater than. This is the same thing as turning it around and writing x is greater than 3. In both cases, the small end of the symbol is closest to the 3, and the wide end of the symbol is closest to the variable x. This means that 3 is on the left side, and the unknown or the variable is on the right side. Because we don't have an or equal to underneath the inequality, we will draw an open circle at 3 and not fill it in. The variable is on the wide end of the symbol, whichever way you write it, which always means go right. If the variable is on the wide end, you go right. If the variable is on the little end, you go left. Once I have it on the number line, writing it in interval notation is not so difficult. My interval notation will mimic what it looks like on the number line. For an open circle, I use a round parentheses. For a solid circle, I would use a square parentheses. Then I have 3 on the left, comma, and the arrow goes forever to the right towards infinity. That's my solution in interval notation. In other words, provided the x is greater than 3, then 5x will be smaller than 8x minus 9. Let's take a look at the next problem. On the next problem, I have a longer and more involved inequality. I will need some space in order to work this one out. This will give me 11b, and distributing the 2 across the parentheses, I will get plus 2b and minus 10, greater than 2b plus 45. Remember that your inequality is balancing or not balancing on the inequality symbol. I already have 2 like terms on the left side. I don't need to move them by adding or subtracting them. I just need to combine them. This would give me 13b on the left minus 10, still greater than 2b plus 45. Which one is smaller, 2b or 13b? They're both positive, so I take the one with the smaller number. If one were positive and one were negative, I would always move the negative one. So I'm going to subtract the 2b, which will put my b term on the left side. Since negative 10 does not have b attached, I'm going to add 10 to move it away from the term with the variable b. When I combine these, this will give me 11b on the left. The symbol is not reversed because I was only adding or subtracting. And on the right, I will get 55. Now I need to divide both sides by a positive 11. Dividing by a positive number does not cause the symbol to reverse. Dividing by a negative will literally turn the symbol around. And I'll show you what I mean in a second. This leads us to b is greater than 5. What do I mean by turn the symbol around? Let's suppose that I take the problem from line 2, but I move the 13b instead of the 2b. Let me rewrite the inequality here. Instead of subtracting 2b, what if I had instead subtracted 13b? Since the b's would end up on the right side of the equation, I would move the 45 by subtracting 45. This step does not require reversing the inequality because I am only subtracting. It is only multiplication and division by a negative that causes the symbol to reverse. This would give me negative 55 greater than negative 11b. Now I have the problem. To get the b by itself, I need to divide by negative 11. This would give me negative 11b divided by negative 11 less than negative 55 divided by negative 11. The number I'm dividing by is negative. It doesn't matter if the numerators are positive or negative, only if the number I'm dividing or multiplying both sides by is negative. This will give me a 5 on the left and a b on the right, but the symbol, and only the symbol, has to turn around. Can you see that these are, in fact, equal? This one on the left shows the 5 on the little end, and so does this one on the right. 5 is on the little end. B is on the big end in both representations. On the method on the right, I had to remember to reverse the inequality because I divided both sides by a negative. Let's put the solution on the number line. On the number line, I'm going to have an open circle at 5 because I don't have the or equal to. Should I go left or should I go right? The variable is on the wide end of the symbol, which means go right. To write the answer in interval notation, for open circles, I use round parentheses. The number it starts at is 5, and it continues to the right forever, 5 to infinity. Let's take a look at another problem. On the next problem, I have a quadratic equation involved in the inequality. They want me to graph the solution. To do this, I need to first think about what it would look like if I were to graph it. There are multiple ways of figuring out quadratic inequalities. I'll give you two different methods. One method is simply to graph what x squared minus 5x plus 4 would look like. To say it is greater than or equal to 0 means the y value is greater than 0 or equal to 0. If I were to graph x squared minus 5x plus 4, I would need to find the vertex, the y-intercept, and the x-intercepts. To find the vertex, you could use the formula that the h value at the vertex is given by negative b over 2a. b is itself a negative 5, so this is a double negative 5 over 2 times a, which is 1. This would be at positive 5/2. The y value at the vertex, which is given with the variable k, would be whatever I get when I plug that 5/2 value back into the formula. This would give me 5/2 quantity squared minus 5 times 5/2 plus 4. This would give me negative 5/2 squared is 25/4. Then this would give me minus 25/2 plus 4. This is the same as 6.25 minus 12.5 plus 4. In other words, I should end up with 10.25 and negative 2.25. If you leave them in fraction form, you would need a common denominator, which would be fourths, and you would write 25 over 4 minus 50 over 4 by multiplying top and bottom by 2, and 16 over 4 by multiplying top and bottom by 4. That would give me 25 minus 50 plus 16, which would be the same as writing negative 25 plus 16, or negative 9 divided by 4, which is a negative 2.25. If I were to graph this on a graph, what would it look like? If I were to graph it, I would get this graph you see here on the lower left. In this case, what we're asking is for this function to be greater than or equal to 0. Greater than or equal to 0 means the entire graph is above the x-axis or on the x-axis. If I expand my graph a little bit, it looks as though that is probably happening between the x values of 1 right here and the x value of 4. That is what I am expecting to find, that between 1 and 4, the value goes below. So on my particular inequality, I want the graph to be above 0, which means I'm expecting my solution to be from negative infinity up to 1 and include 1. Also add on to that the region from 4 to positive infinity. Note the use of the square brackets to include the or equal to zeros of the x-intercepts at 1 and 4. Now, how would I find this algebraically? Let's return to the equation x squared minus 5x plus 4 and show how to do it algebraically. Since you will not have a graphing utility on the exam, you need to be able to do it by hand. Reducing the picture again so we have a little bit more room to work, what I need to do now is I need to factor this quadratic if I can. This does factor into two different binomial factors. I get the signs being the same because the constant's positive, And since the middle term is negative, that means they're both negative. Factors of 4 that add to give me -5 are -1 and -4. That means that it will equal 0 at 1 and it will equal 0 at 4. The reason to have these here. Now, when will it be positive and negative? Again, there are various ways to do this, but I like to make sort of a table out of the factors in my problem. And then I'm going to draw a number line. And on the number line, I'm going to put numbers that represent the values of the solutions for each factor. So I'm going to need 1 and 4. And I'm going to have 3 number lines, one for the combined expression, and one for each individual factor. I can mark off where 1 and where 4 are on all 3 with single vertical bars. Now, we need test points. We need a point that is less than 1, between 1 and 4, and greater than 4. And again, I chose 1 and 4 because those are the solutions that match the factors x minus 1 and x minus 4. The easiest number to use for a test point below 1 is 0. The easiest point to use between 1 and 4 might be 2. The easiest point to use above 4 is probably 5. Now I use the test point in each of my factors. If I put in 0 for x, I would get a negative. I'm not trying to determine what the actual value is. I just need positive or negative. If I plug 2 into this, I get 2 minus 1, which is positive 1. Again, I just need the sign. If I plug in 5, I also get a positive. In general, since this factor is linear, keep in mind that slanted lines, once they've crossed over the x-axis, are never going to come back again. This line is crossing the y-axis at -1 and the x-axis at 1. It's negative until it gets to 1, and after 1, it's positive. Again, negative till it gets to the value 1 and positive forever after. What about x minus 4? X minus 4 crosses the y-axis at -4 and the x-axis at 4. I would expect it to stay negative until I get to 4 and after that be positive. 0 minus 4 is still negative. 2 minus 4 is still negative, but 5 minus 4 is positive. To get the combination, I don't need to plug in the test point. I just need to look at the signs. A negative times a negative is positive. A positive times a negative is negative, and a positive times a positive is positive. This means that it is positive below 1 and above 4. It will be 0 at 1 and at 4. Now let's put it on the number line. This does meet with what I saw on the original graph. On the number line, I will have a solid filled-in ball at 1 to represent the square bracket, and a solid filled-in ball at 4 to represent the square bracket. To show it goes to the left of 1, I go off to the left, and to the right of 4, I go off to the right. Let's take a look at the next problem. In this problem, we have another quadratic inequality, which we need to solve. In this case, it is supposed to be less than or equal to 0, which means the y value can either be 0 or negative. In this case, I'm going to do it strictly by the algebra. If you want to put the graph into Desmos and see if it meets our expectations, you can do that now. Looking at this one, I'm going to factor x squared minus 9x plus 18 if I can. Since it's already less than or equal to 0, I don't need to move any terms around. I just need to factor. When I factor it, I get x squared splitting as x and x. Signs in the middle are the same because it's a positive constant, and they're both negative because I have a negative middle term. I need two factors of 18 that add to give me negative 9. It's negative 6 and negative 3. Now I'm going to write down my factor table of x minus 6 and x minus 3. Then I'm going to do the combination. To skip writing everything again, I'm just going to write combo. I have a line for each of the three different ones, each individual factor and their combination. The factor x minus 6 has solution 6. Draw a vertical line at 6. The factor x minus 3 has a solution at 3. Draw a vertical line at 3. Make sure you put the vertical lines in number line order. Now let's find test points. Give me an easy number less than 3. You could use 0, 1, or 2. I choose to use 0. Give me an easy number between 3 and 6. 4 and 5 are the best choices. I'm going to use 4. The easiest number greater than 6 would be 7. Plug the test points into the single factors. 0 minus 6 is still negative. 4 minus 6 is negative. I expect the linear factor to change at its solution 6. 7 minus 6 is positive, and it does change right there. I expect x minus 3, the linear factor, to change at its solution 3. 0 minus 3 is negative, but 4 minus 3 is positive. It will not change signs again. The combination of these multiplied together will give me a positive, negative, positive. This time, however, notice that in the original problem, I am looking for something that is less than or equal to 0. Less than means negative. I'm looking for this region right here. That means because of the or equal to, I will put a solid ball at 3 and a solid ball at 6, and I need to stay between them, so I will connect between like that. Now I need to put it in interval notation. I need a square bracket at 3 on the left side, comma, stop at 6, and square bracket for the solid ball. Let's take a look at the next problem. The next problem is another quadratic, but it does not have the x term. Let's see how this changes and affects the way we solve it. In this case, I again have 0 on one side by itself. All I need to do, if possible, is factor it. I have 25x squared minus 81 less than or equal to 0. Because I don't have an x term, my only hope is that it is the difference of two squares, and it is. I can factor this as 5x minus 9 times the quantity 5x plus 9. And this needs to be less than or equal to 0. The solutions that go with each of these would be as follows. Set the 5x minus 9 equal to 0 and solve. I would get 5x is 9, or x equals 9/5. The other factor, 5x plus 9, would solve similarly, but I would get instead that x is negative 9/5. Now let's produce a table based on those two factors. I'll have the factor 5x minus 9 and the factor 5x plus 9 and their combination. Draw one number line for each of those. One of them has its solution at negative 9/5, which will be to the left of positive 9/5. Put the two lines on the graph in number line order. Negative 9.5 is between negative 1 and negative 2. That means negative 3 is definitely to its left. I'll use that for a test point. The easiest number between negative 9/5 and positive 9/5 is 0. 2 would be the simplest number to check above 9/5. Now I can plug in my test points into each individual factor to check their sign. 5 times negative 3 is negative 15 minus 9 is still negative. 0 times 5 is 0 minus 9 is still negative. 2 times 5 is 10. 10 minus 9 is positive 1. It did what I expected and changed signs at its solution, positive 9/5. I expect the factor 5x plus 9 to change sign at its solution, negative 9/5. Plug in the test point, negative 3. I get negative 15 plus 9, which is a negative 6, so it's still negative. Plug in test point 0 to get positive 9. It did change at its solution. Now plug in test point 2 and verify that it does not change again. The combination of those factors multiplied together will give me a positive, a negative, and another positive. In this problem, I am again looking for less than or equal to 0. Equal to 0 means right at their solutions, negative 9/5 and 9/5. Less than means negative. I'm expecting the solution to be between negative 9/5 and positive 9/5. On the graph, negative 9/5 is 4/5 of the way between negative 1 and negative 2. That would be right here. 9/5 is 4/5 of the way between 1 and 2, or here. Since the negatives are between those two, then I would connect them with a solid ball. What we have found are the x values that you can use to plug into the original 25x squared minus 81 that will keep 25x squared minus 81 negative or 0. Let's look at the next problem. This says solve the inequality, then graph it. So first we will try to graph this by factoring the left side. Notice we have 0 isolated on the right. So I have 2x squared plus 11x plus 15 greater than or equal to 0. 2x squared has to split as 2x and x. 15, however, could split as 1 and 15, or 3 and 5. Since the signs in the middle are the same, we'll be adding the products together, and they're both positive. I can go ahead and write that much in. In that case, 15 and 1 is a bad choice because then my product will be at least 15, if not more. So I'm going to use 3 and 5. The question is, do I put the 3 here and the 5 here, or the 5 here and the 3 here? If I do the 3 on the left, I get 3x and 10x, but that gives me 13x and not 11. That can't be correct. What if I tried 5 on the left and 3 on the right? That would give me 5x in the middle and 6x on the outside to add to give me 11. That has to be correct. So it is 2x plus 5 times quantity x plus 3 greater than or equal to 0. Now let's find the solutions that match those factors. 2x plus 5 equal to 0, I would move the 5 to the other side to get 2x equals negative 5, or x equals negative 5 over 2. The other factor, x plus 3 equal to 0, would give me the solution of negative 3. Now I'm going to take these and I'm going to put them into their table. I have the factor 2x plus 5 and the factor x plus 3 and their combination. One horizontal number line for each factor and one for the combination. 2x plus 5 has its solution at negative 5 halves, which will make the vertical bar on the left. Where is negative 3 in relation to negative 5 halves? Uh-oh, it looks like I put it in the wrong place. Negative 3 is smaller than negative 5 halves, so I need to make the negative 3 be the one on the left and the negative 5 halves be the one on the right. Be sure you get them in number line order. Now find a test point. One easy test point below negative 3 is negative 4. There aren't many good test points between negative 3 and negative 5 halves, but you can think of negative 5 halves as a negative 2.5. A test point might be negative 2.75. It's not great, but it'll work. What's a good test point above negative 5 halves? You can use all kinds of numbers, but 0 would probably be easiest. Now let's plug in our test points and see what the sign of each factor is. Negative 4 times 2 is negative 8 plus 5 is still negative. Negative 2.75 doubled would be more than negative 5. Added to 5 would still be negative. 0 times 2 is 0, plus 5 is now positive. For the second factor, negative 4 plus 3 would give me a negative, but negative 2.75 plus 3 would be positive. Small, but positive. 0 plus 3 would also be positive. Their combination, multiplied together, would be positive, negative, positive. In this case, we have or equal to, so we'll use solid balls. Without the solid line on the bottom of the inequality, you would leave the balls open or empty. I need a solid ball at negative 3 and another solid ball at negative 2.5, which is very close to that. Now I need to go which way? My original problem said greater than or equal to 0. Where am I going to be greater than or equal to 0? I equal 0 at the vertical bars or the solutions to each factor. I'm greater than 0 when I'm positive. That would be on the far right and the far left. So from negative 5 halves to the right and negative 3 halves to the left. The interval notation matches the form of the number line. Negative infinity at the far left, comma, negative 3, square bracket for solid circle, and or equal to on the inequality, and union, square bracket at negative 5 halves, comma, positive infinity, always round with infinity and negative infinity. I believe we have one more example. On this last example, notice that we do not have the quadratic equation all on the left side. In order to do this, we need to first move the negative 1 to the other side so we can have 0 by itself. I'm going to move that over and rewrite it as x squared minus x minus 2 greater than or equal to 0. I don't know why all of these are equal to. The next step is to factor the left. So I factor it as x and x. 2 has to go as 2 and 1, but this time the signs in the middle have to be opposites. To end up with a negative when I subtract, I should have a negative 2x and a positive 1x. The solutions that match each factor is going to be x equal negative 1 and x equal 2. Putting these into a table, I have the factor x plus 1 and the factor x minus 2 and their combination. One horizontal line for each factor and one for the combination. The solution for x plus 1 is negative 1, which is to the left of x equal 2. For test points, we can use negative 2, we can use 0, and we can use 3. Anything in between the numbers, but not on the vertical line. Negative 2 plus 1 is still negative. 0 plus 1 is positive, and 3 plus 1 is positive. Negative 2 minus 2 is definitely negative. 0 minus 2 is still negative, but 3 minus 2 is positive. Negative times negative is positive, positive negative is negative, positive positive is positive. I was looking for greater than or equal to. Greater than or equal to, going back over here to my rewriting, means positive or 0. It will be 0 at the two solutions for the factors, negative 1, solid ball, and 2, solid ball. Greater than means positive. That's far left and far right. I move off to the far right and off to the far left. In interval notation, it mimics the number line form of the solution. And remember to use square brackets where you have solid filled in balls. There may be one other problem. Let's see. Yes, one last problem to work for this section. Solve the following inequality. In this case, it's not or equal to, so our circle should be empty. I have 3 factors already factored out. The solutions that match the factors in order are negative 4, negative 3, and negative 1. Let's produce the table. I would have factor x plus 4, factor x plus 3, factor x plus 1, and their combination. I need to have a horizontal line for each factor and one for the combination. I need to put the solutions for each factor onto the table as vertical lines. Negative 4 is to the far left. Negative 3 comes next, and negative 1 is last. You may need to extend your lines out to make sure that you have a full grid. Test points to the left of negative 4 would be negative 5, negative 6, negative 7, and so on. I don't have a great choice between negative 4 and negative 3, so I will have to use negative 3.5. Between negative 3 and negative 1, the best choice would be negative 2. Above negative 1, I could use 0 or 1 or 2. Plugging the test points into the line would give me the following signs. Negative 5 plus 4 is negative, negative 3.5 plus 4 is barely positive, negative 2 plus 4 is positive, 0 plus 4 is positive. Looking at the next row, Negative 5 plus 3 is still negative. Negative 3.5 plus 3 is also negative, but negative 2 plus 3, that would be positive. And 0 plus 3 is positive. The last factor, x plus 1, should be changing sign at negative 1, its solution. Negative 5 plus 1 is negative. Negative 3.5 plus 1 is negative. Negative 2 plus 1 is negative, but 0 plus 1 is positive. These factors were all originally multiplied together. A negative times a negative times a negative is still negative. A positive times a negative times a negative is positive. A positive times a positive times a negative is negative. And 3 positives multiplied are still positive. My original problem said less than 0, which means negative. If I want to make them negative, I need the one on the far left and the one second from the right. I don't have or equal to 0, so I will have empty balls at negative 4, negative 3, and negative 1. Empty balls at negative 4, negative 3, and negative 1. I'll be negative if I choose x values to the left of negative 4, or if I choose x values between negative 3 and negative 1. Now to get the solution, I need to mimic the number line solution in interval notation. Far left forever is negative infinity, comma, stop at negative 4, but it's empty, so use round parentheses. Plus, don't be done yet, there's more to come with a union symbol, round at negative 3, and go up to negative 1, but don't include negative 1 either. This is how you can solve a polynomial inequality.